Welcome to Brain Vision.
So, when a particle of a charge q is accelerated through a potential difference, it gains kinetic energy of value of magnitude q times the potential difference. Here, the particle is electron, so the charge is negative 1.6 times 10 to the power minus 19 coulomb, and mass is the mass of the electron, which is 9.11 times 10 to the power minus 31 kg. Now, kinetic energy is also given by half m times v square. Let's call this VE to separate these two V. So let's solve for the velocity of the electron now. So this will be equal to 2 times the charge of the electron times potential difference over m, and we have a root over of that, and we find the velocity to be 2.65 times 10 to the power 7 meter per second. Now for the next step, we use Newton's law, which gives force is equal to mass times acceleration. And when a particle moves in a circular path of radius r, its acceleration is given by v square over r. And this is the radial acceleration, not the tangential acceleration. So centripetal force will then be equal to mass times v square over r. And since here the centripetal force is caused by the magnetic field, so this force should be equal to the magnitude of the magnetic force. So yeah, and we take the magnitude of that also. So this is equal to q times v sine phi, and here phi is 90 degree because the velocity and magnetic field are perpendicular here. So this gives the magnetic field to be equal to mass times velocity over the magnitude of charge times the radius, and the radius is given to be 0.18 meter. So we solve this for b and we get the magnitude of b to be 8.38 times 10 to the power minus 4 Tesla. This is the magnitude of the magnetic field here. So as you can see here, the smaller the radius gets for the circular path, the larger will be the magnitude of the magnetic field.